the note online. So when you go back to study, if you want to look at that, we'll close that down, and we are ready to go. Okay, so organization of the elements and the periodic table. Again, you can write that down, and we've got the date there, September the 16th. Again, you can check that back to when you go back if you're going to study using Google Classroom, which is a good thing to do. So when you guys go to study, I'm hoping you'll have maybe a phone or a device nearby, and then you'll have your notes, and then you can go to each of those days and you can see if you understand what's going on. And if you can't, you can always watch the video a little bit or do whatever you need to do. Okay, so for the last part of the week, we've looked at physical versus chemical properties and physical versus chemical changes, and we've finished that off. And now we're ready to move on to the next part of chemistry, where we're going to look at the elements themselves. Just to look back, why do we look at physical and chemical properties and physical and chemical changes? Because that's how we observe chemistry. In order to observe chemical reactions taking place, number one, we have to be able to describe them. Those are the physical properties, right? A white opaque powder. And then when things undergo change, we have to, again, be able to describe the final products, and we can then understand whether we've had a chemical change if those products' characteristics are greatly different than the reactants, right? And we can see that that takes place. So now we're ready to go on to the chemistry, to talk about the atoms, to talk about the elements. And that's what we will be doing just before our test that's going to come later on next week. We're going to finish off by looking at the elements to begin with, and then we're going to draw some atoms, not today, but in next week, draw some atoms and represent them with what we call Bohr diagrams, which I think you've probably already done. So, organization and the periodic table. Here I have a periodic table in front of you. I have a periodic table that you can click on and look at when doing some homework on Google Classroom. But you can take a look at this one up here. You don't have to necessarily have it open on your device or on your phone. In terms of the elements, and that's already the heading, you don't need to rewrite the elements, but please write this information down about the elements. Yep. Yeah, actually, you know what? Change that to 118. If you want, this is an old note, and I'm too lazy to change the thing. But I do know for certain that they now know up to 118 elements. All right, the good stuff, good background knowledge. You must have read that somewhere, perhaps online. And yeah, we now have up to 118. That actually brings us into this position. And they've actually given proper names to everything up to 118. You'll notice on this old periodic table, we've got some funny names down here at the bottom, UUN and UUU. And these names are based on the number themselves. So if I'm looking at element 110, it's unilium. What does un stand for? French. Yep. One. So un, and nil. What's nil? Yep. Zero, like in a soccer game. So at one point, they were naming the elements based on the number for the ones that they were discovering at the end. But then they realized, hey, that's kind of lame. So the chemists, the old wise chemists that get together once a year in Geneva, Switzerland, and they're part of a special group called the Union of Applied Chemists. And what they do is they determine how we name things. They have come up with names for these. And I read them the other day on an online post, but I didn't write them down. I do want to write them down because I do want to put in the new names for those that go up there. But you're right, all the way up to 118, all right? 86 of them are naturally occurring. On this periodic table here, if the symbol is filled in with a color, it's a naturally occurring element. It means you or a chemist could go to the earth somewhere, could dig something up, do some chemical reactions to separate it out and find those elements. If they don't have any color within them, then they're man-made, all right? It means you can't dig them up, but they could be made with a particle accelerator, all right? That's how we make elements. We don't make elements using chemistry. We make elements using nuclear physics. Because when you make a new element, you're changing the nucleus. Does anybody remember what the nucleus of the atom is or where the nucleus is? You seem to have a group that seems to know. Yep. It's in the center. Does anybody remember what particles are in the nucleus? If you don't worry. I'm going to review this. Yep. Neutrons and protons. Excellent. Where do the electrons reside? Yep. Yeah, around it in orbit. Excellent. So you guys already have a good understanding of what elements are. When physicists change elements and make new ones, they're changing the nucleus. They're changing the protons that are in them. How do they do that? They can smash two lighter elements together and hope that their nuclei will stick together and make a new heavy nucleus. All right? And so that's what they do. And they need to use what I said is particle accelerators. There's a really big particle accelerator that just kind of turned on probably about 5 or 6 years ago. It's in France and Switzerland. It's such a big particle accelerator. It's a giant ring that's like 50 kilometers in diameter under the ground, and they accelerate these particles. Does anybody know what that particular one is called? Correct. It's the last one is Hadron Collider, right? And it's got an L on the front. It's really big. It's called the Large Hadron Collider because it's huge, and it's the biggest particle accelerator in the world. They don't make elements there. They're testing other fundamental things about protons themselves and neutrons themselves. But there are lots of other particle accelerators in the world that try to squeeze these nuclei together and make new ones. And that's how the man-made ones are made, all right? They don't exist very long. They can't make chemicals out of them because once they're made, they're so unstable, the nucleus blows apart in a nuclear reaction, and then they break apart. But chemists and physicists, they like to put them together to say, hey, we did it. We made a 118, all right? Yes?
I heard that, like, science thought,
Large Hadron Collider? Yep. No, that's fun. I'm going to clear up what you've read, but I'm not laughing at you. I'm just laughing at the fact that that information is still out there. When you can keep writing here as I'm talking, because I do have a lot of information on this, and you guys seem to be quite interested. When they were going to turn on the Large Hadron Collider, right? When they were going to fire it up, what they do is they get a beam of protons going in one direction, and then they get a beam of protons going in the other direction. And they have them going around in two different tunnels in this thing, and then in the end they can steer where they go. They bring them together and smash. They run them into each other. All right. It was believed, well, it was hypothesized by not really physicists, but more conspiracy theorists, that if you squeeze that much material into one spot, that it would create a little black hole. And some believed that black hole would then instantaneously start to suck everything into it, and in the end, the Earth would have been engulfed, and we would have destroyed the solar system because everything would have been sucked into this little black hole. That never was ever that was never going to take place. The real physicists knew that wasn't the case. But you know how something is on the internet. Somebody gets a hold of it, and then boom, 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 and then everybody feared, oh goodness, this is going to be the end of the world. Well, they turned it on, they smashed their protons together, and we didn't see the existence of a universe-ending black hole, or we wouldn't be here to discuss it. All right. Periods are the horizontal rows that run across. So these are the periods. All right. You might think, why would someone call them periods? And it has to do with the way that the elements behave. Their chemical reactivity repeats itself over and over again. The groups that go down, the vertical columns up and down, they're called groups. Sometimes they're called families. Actually, I'm going to put that in brackets here. Groups or families. All right? Like brothers and sisters. Right? If you're in a family, your brothers and sisters will have the similar characteristics to you. Might have similar hair color, might have similar body size. So the chemicals that are up and down, they have similar characteristics, so we call them families. Yep. You bet it would be. Right here, the noble gases, they all behave the same way. They're all gases. Do you know why they're called noble? Correct. They don't react very well. So this is the family of the noble gases. All right? And we're going to write that information down in a moment. Again, the reason they're called periods is because here we have the family called the alkali metals. They all behave very similarly. When you work away across the periodic table, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, you get to neon, the noble gas. When you go to the next period, you have an element that behaves very similar to the one that's just above it. Anything that happens over and over again, repeating, we say it's periodic. You might have heard that term before. Like we would say that a pendulum in a big clock is periodic because it does the same thing over and over again. We say that the phases of the moon are periodic because we see a full moon every 28 days or so. The table of elements is periodic because every time we get to the end of a row, we see the same property over and over again. And therefore, they're called periods when we move this way, because when you get to the start, it does the same thing. It reacts the same way. On my table here, there are periods 1, 2, 3, 4, 5 labeled on there. In a moment, when we get done writing the note and we start doing some things, I'm going to have you open your periodic table on Google Classroom, and using the little pen feature, you can write down the periods on your periodic table as well. The groups, they number across, and you can see their numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 families on the periodic table, okay, or 18 groups. So periods go across, groups up and down. All right. So let's make this chart, and let's just do a little practice. You don't need to make the actual chart. That was just easiest for me to write, to write it down. You could write it simply like this. And you don't have to write down complete the following chart. Just do this, do this, do this. Right? On your paper, just do that. Element, there it is there. We're going to pick out the period number. We're going to pick out the group number. So really, it's like finding grids on a map. Like when you looked for maps, locations. Remember if you've ever had to do that type of thing? Picking the grids. So I'm going to just wait patiently as some of you get this written down. If you've already got it written down because you're looking ahead, you could write in what the period is. You could find gold. Gold has a symbol of AU. It's right here. All right, so you should be able to find the period number, and you should be able to find the group number. The next one is lead. Lead is PB, right there. It's actually close to gold. We already talked about how the alchemists tried to turn the lead into gold. I just told you how you could create new elements by smashing other ones together. But to go backwards and pull pieces out of the nucleus, that's a hard thing to do. It's not easy to take pieces out. It's easier to squish them together and put them together. You know what? I don't know of any easy way to pull pieces out of the nucleus to turn lead into gold. To add things, it's easy. You just run them into each other really hard and hopefully they squish. What you'd need to do is you'd need to run into it in such a way that makes it break a piece off, and that's a tough thing to do. Yeah, because the nucleus is really sticky. When you put protons and neutrons together in the nucleus, there's a special force that holds them all together in there. So when things get close, they either take off away or they stick tight, but they don't run into each other like, you know what I mean, like two billiard balls. It's not exactly the same as that. So it's really hard to do. Okay, so let's go through this. Does somebody have the period number and group number for gold? Somebody have that? Yeah, Eric, what do you got? 6 and 11. All right, so we're checking it on the grid. I like it. Period number and group number for lead. Yep. 6 and 14. In this case, I'm providing you with a grid location. So period number 6 Group number 1, locate that symbol. And if you can't say it, it's okay. You can tell me what the symbol is. What's the symbol for 6 and 1? Yep. CS. CS. That's cesium. That's cesium. You don't have to write in cesium. I'm not that concerned about it. Yeah, that's fine. Cesium. C-E-S-I-U-M. And the last one. 3 as the period number and group 17. 3 as the period number and group 17. Jacob, what do you think? Did you track it down? 3 and 17. You can't see that far? That's exciting. Where am I heading? Which one am I stopping at? Is it this one? 17? 3? And you can't see those letters?
I see the letters.
I just want the letters. What is it? It's an L. Cl. Called chlorine. Called chlorine. All right? When you guys are doing a test, I'm going to be supplying you with a periodic table, so you won't have to be squinting up here. You'll have that all right in front of you. Okay? All right. Physical states of the elements. Solids are gray. So just like on my table, and that's a standard thing for all tables. Liquids are blue. Only 2 of them. And gases are red. Yep.
Can I say something about the bromine?
Sure, go ahead. What do you got? You got some information?
Bromine and mercury, they might be liquid, so that's only at room temperature. If you were to heat or to
Cool.
they would solidify.
That's true. That's true about all elements, all substances. And like you said, at room temperature, in science we have a special term for that. We call it SATP. It stands for standard ambient temperature and pressure. The environmental conditions that we experience in the laboratory. So if we had a hunk of whatever in the laboratory, that's the state it would be under laboratory conditions. But that's true. Any of these substances will have a freezing point, a melting point, and a boiling point. If we adjust those things, we can get them to melt. Yep, somebody wanted to add something? Correct. Something you'd experience under a regular temperature. Now, I'd like to try something right now with Google Classroom. At this point, and I'm going to switch to it as well, let's go to Google Classroom. All right, see if we can do this. If you're on the Chromebooks, this might be a little tricky, but you might be able to do it. What I'd like you to do right now is open the periodic table that I've given you. Now, when you guys open it, I want you to use the writing feature. Do you know what I mean? So open it so that you can write on it. Are we all aware how to do that at this point, I think, as a group? Are you not going to have it on there, are you? No, with the Chromebooks, you're not going to have access to that. That's too bad because the Chromebooks are going to be, the Chromebooks this isn't going to work for. That's too bad. Do you have your phone?
It's almost dead.
It's almost dead. Let me see if I can find a couple more. You know what? These iPads here will be charged enough for you guys to use them. So here's 2 iPads. If you have a Chromebook, come up. I know there's 3 of you. I'm going to see if I can find one more. One iPad? Did you have one? You have one? All right. That's okay. If you're using it, it's not a problem. Okay. Yeah. Sorry, man. You'll be fine. Here's what I want you to do in the writing mode. Number 1, what I'd like you to try to do, and I'm going to bring this up here, is I'd like you to try to number the periods. Okay? So you have to be in the writing mode. You can't be in looking at it as a Google Doc. You have to be in that writing mode. Really? I didn't give you a copy. Okay, you can't do this. It says view only. You can't do it. You could open it up and write on it. This is exciting. You've got the blank periodic table. Are you guys looking at the blank period? Oh, you're able to write on that view only one. Nice job. So, yeah, that's what I wanted you to do. I wanted you to write the period numbers on it. What I wanted you to do was do something like this. 1, oh, no, I'm not writing. 2, 3, 4, 5, 6, 7, right? And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Are you able to write on it? You can zoom in. Are you able to write on it? You already wrote on it? I already did that. I want you to see, can you change the colors? Can you make the color into red? And could you highlight the gases? Now, you might be able to write, just put a box around it. Is there a highlighter? On the writing, there might even be a highlighter. So if you could do the highlighter and turn the highlighter into red, and then you could, I'm going to just put a, oh, that's blue. That's not red. I'm going to put a box around it. So I'm going to put a box around mine just to, you know what I mean? And I want you to square up all those gases. All right? Bromine. Oh, bromine's a liquid. Darn, I messed it up. I can't fix mine. So let's see. Here. What you do here is click on that pen. Just zoom in. Zoom in. You can zoom in super close. Zoom in. Zoom in more.
But still.
Here. Watch this. Watch. Here, we can make that really skinny. All right. So we can move that over. All right. Ta-da. No? That's nice, isn't it? That's fun. I think that's a fun thing to do, isn't it? You can make those skinnier, eh? Go down to the bottom, push on it, and see, now you got skinny writing. Now you got skinny writing. Skinny writing? That's easier? It's okay, don't worry about it. Oh, now you use the blank periodic table. That's okay. There is a table there that has actually the stuff on it. You can, so, right, that one, okay? There is a highlighter, isn't there? See here, there's a highlighter. You could then just, if you change the color to red, you could just highlight it in red, like color it. Nice. How about the blue ones? Which ones are blue? Bromine and mercury. Well, if you use the highlighter, then we can write in which ones are gases and which ones are. You understand what needs to be done. You just don't have a device that can do it. I'm sorry about that. So, switch the highlighter to blue. And I already screwed up. Look at there. I made bromine. I've got bromine in red. It doesn't work. I would do that, but it failed a few years ago. I think chalk dust gets inside, and then there's a little light sensor that senses whether the pen is gone. And I think that's covered in chalk dust, and so I got to take it apart and clean it if I want to. I haven't taken it apart in a while, so I'm lazy. I just try not to make mistakes. Mercury. Was everybody able to kind of do that? Brett, you were able to kind of draw that in there? Nice, nice. Don't color in the gray. Just leave everything else. You know what I mean? Don't color everything gray. Just put in the gases. Did I get it right? Did I get all the gases correct? I got the noble gases, fluorine, chlorine, up to nitrogen. And I think that's it. I think we got it. Oh, I did miss hydrogen. That's important. Hydrogen. All right? I'm going to do some other writing, Max, as well. I'm sorry, Max. I'm short one machine. Oh, yours is struggling. Okay, all right. Okay, are we able to continue on?
Okay, I know.
Yeah, I'm sure you do. I'm sure you do. Okay. I'm going to continue on, all right? So I'm going to clear the writing, though, before I do that, because I don't want this to stick around. Oh, my computer is so slow. I got to get a new computer. Okay, let's continue. Which, you're going to save it. You're going to save it. No, you got to, for that particular feature, you've got to press that little disk button in the corner to save it.
Okay.
Do you see what I mean?
Yeah, I got it.
That's going to be your note now. You see what I mean? When you go study, you can go back and look at that. Yeah, the edited one is the one that is yours. The edited one is the one that's yours. Okay, let's keep going. The periodic table is divided into two major groups, metals and non-metals. Were you able to get that? Right? You get that all drawn up there? The metals and non-metals are separated by a staircase line. Yep. It's fine. Keep going. You're going to make it to the end of the class easy by 18%. I've even seen 4% make it through a class. The battery's pretty big. The battery's pretty big. No, he's fine. 18% is plenty. Yep. The staircase line. You've probably seen it before. Runs along here. You might think that chemists just kind of put that there for fun, but that's there based on the properties of the materials. It turns out that the most metallic of all elements is way down here in the corner. It has everything to do with where its electrons are. In the grade 11 university level chemistry, I teach the students in great detail how strongly the electrons are held onto an atom. And how strongly the electrons are held determines how it behaves. Francium does not hang on to its electrons very well. Metals have very weak holds on their electrons. So francium is the best and is the most metallic. Fluorine has the strongest hold on its electrons. We don't count the noble gases because they have something special about their electrons. You guys are pretty bright. What is it special about the noble gases that makes them unreactive about their electrons? I don't know if anybody remembers. Yep. Their shell is full, right? So they don't react much. But fluorine is short one, and it pulls like crazy on other atoms' electrons. It's the best at being a nonmetal. When you take the position of francium, which is the best at being a metal, and you take the position of fluorine, which is the best at being a nonmetal, and you work your way across the table, you end up with this spot that divides those things. Okay? And the reason it's on a stair step is because it's exactly opposite from the most reactive two. So it's not like chemists put it there on, they just decided. They didn't just sit down and decide to put that line there. The way the elements behave determines where the line is. These guys have more metal properties, and these guys don't have metal properties, so they're non-metal. Okay? And so that's how that stair-step line ended up in that position. So let's talk a little bit about the metal's properties. Yeah, we're writing that down. I'm trying to hide this little tab, but it doesn't get out of the way. So you'll have to just notice that there's some writing there. They tend to be gray, like a silvery gray. There are a couple of exceptions. Copper is copper colored and gold is gold colored. It's really bad when we use the same word to describe something, but because copper is such a distinct color, we allow people to describe things as being copper colored. It's copper colored, like an orangey kind of color. Orangey brown, yeah. Gold is definitely gold, like an orangey bright orange, right? Copper and gold in the same row. Maybe that's why they have similarities in that orangey type color. Silver seems to be not the case. It's definitely silver, not copper colored or gold colored. Solids at room temperature except mercury, they're shiny. Now you may have seen metals that aren't shiny, but that's because they've been oxidized. The air has gotten to them and has coated them with a little bit of an oxide. But if you buff it out or you clean it off, you can make it shine. They conduct heat and electricity. Right? We all know that if you leave a spoon in some hot chocolate or hot coffee, that spoon could get very hot because it conducts very well. Electricity, you connect it into a circuit, the metal works very well. Malleable and ductile. Does anybody know what those terms are? Malleable and ductile. Let's deal with one of them. Which one would you like? What is malleable? Just tell me what malleability is, though. It's softer metal. Excellent. That's good. Technically, malleability means you can hammer it flat and you can make a sheet of it. So you can roll it into a sheet. It can be rolled out. Some you don't have to. These are super soft. I can roll it out. I can cut it with a butter knife and I can roll it with a rolling pin. Yeah. But some of them are harder. You do need to heat them up. They change in properties. Correct. Ductile. Exactly. To stretch it out into a wire. All right? So one is flattening into a sheet, and the other one is being able to stretch it into a wire. Excellent. Good stuff. This is a lot of review for you guys. You seem to have a lot of information. That's awesome. I got people writing. Okay, I'm noticing Justin's still writing off of the slide. Are you good? Anybody else still writing off the slide? I know some of you guys are writing ahead. That's awesome. I don't care. Non-metals. That's the nice thing about having the notes on the devices, right? If you don't have to wait around. You can get ahead, or if you fall behind, you keep writing. Now, I'm not going to make you write those all out, but we're going to write those on our blank table. Oh, you're taking notes on my notes. That's nice. So you've opened it up so you can write on it. Mm-hmm. Interesting technique. I am a fan of writing the whole thing out in order to learn it the best, right? But we'll see how we do on our first test, and then maybe we'll have a discussion on whether that needs to adjust. Right. But that's a technique that to me is valid. That is good. But we'll see how it goes, right? If we have to adjust, we'll talk about it. Okay. Very similar. But writing is good. Writing is a learning thing. You have to say it in your brain. You have to make your hand do it. It's a learning procedure. So nonmetals, they're up over here. They don't conduct very well. They don't conduct at all. There are some along the stair-step line we call metalloids. Some of them can be semiconductors. You got to energize them a little bit. You got to give them a little bit of a push in order to make the electricity flow. But the nonmetals are non-conductors. They're brittle, unless they're gases, then they're gases. And they're dull. They're not shiny. And really, their properties vary. We can't really just say that they're all brittle because these solids are brittle, but these guys are gases. And this is a liquid, kind of a brittle liquid. You can pour a liquid, right? So really, their properties vary. There are no really defining properties like metals. Metals are very similar. Expressing tired of writing notes? All right. Justin, you're writing ahead now or behind? Oh, awesome. Okay, you're writing the symbols of the elements here, right? Don't write this all down. Oh, actually, you know what? No, I do want this slide written down. But this slide here that says you will need to learn for a quiz that we're going to have on, I wanted it on Monday, but maybe we'll have it on Tuesday. Don't write this down. I'm going to get you to use your blank periodic table to write these down. So, write down this. I'm going to give you a quiz. I'm going to give you a quiz on the symbols and names of the first 20 elements, and then a few more. I'm not going to get you to write down that big long list. When you're studying it, you could go back to the slide on Google Classroom, right? You can go back to that without writing it all out and learn those. Or you could use your periodic table to learn them, however you want to learn them. I do want you to write this information down because it is important. When you write down your element symbols on the quiz or on a test, the first letter must be a capital. It must be. That's just the way it is. And the second letter must be lowercase. So you have to do that when you're writing it. And I know some of you guys, your writing is, questionable at best, but that's okay. But I do need you to concentrate on the first letter being a capital and the second letter being lowercase. Okay? So hydrogen, when it's just one letter, capital H. Helium, 2 letters, H-E, capital H, lowercase e. Some of the funny ones come from their Latin names. That's why they have goofy symbols that don't make any sense. Iron is Fe. It comes from the Latin name ferrum. All right? If you've taken French and your French teacher has taught you about a train, right? The name of a train, I believe, is a chemin de fer. And I think it means like a cart that runs on iron because the rails are made of iron. So I think of that, the fer of the French word for iron. And that's how I remember Fe. Okay? Copper is cuprum. I have no way of I don't know a word that I can associate for you. I just remember that it's cuprum because I'm a chemistry teacher and I remember a lot of that stuff because that's what my job is. A cup of rum. What does that have to do with copper? A copper cup? Yeah. So like a copper cup, you're going to drink your rum out of a copper cup? Oh, that's good stuff. So Nolan is not picky on how he consumes his rum. By the way, this is going on the internet. So when your parents check this out, they're going to be very concerned, Nolan. I'm just saying. Yep.
I was saying, apparently back in the some people remember things by relating it.
Yes. No. I agree. So that you're right. That is a good way of doing it. I don't personally have one, but no, you're right. That is a good way to remember that stuff. You are correct. Word association, it's called. Yep. Yeah, you can. Gold, AU. Aurum. Gold in French. Again, I remember gold in French is or, right? Except it starts with an O, but it's a similar thing. Lead, PB. Literally, it's called plumbum. Yeah. Now, you can remember that because people who used to work with lead and lead pipes, what do you call someone who works with lead pipes? A plumber, and it's got a B in it. And that's because it comes from the original term. Plumbers originally worked with lead pipes, and hence they were workers of plumbum, right? You know what I mean? So, you know, like a baker, a plumber worked with lead. Now we obviously don't use lead, but that's how you can remember that one. Okay, so the next slide has these list of elements that I'm going to quiz you on Tuesday, all right, at the beginning of Tuesday. And don't write these all out right now. You can use this slide to memorize it if you want. or you can go back and rewrite it, but I don't think it's very useful. The first 20, I'm asking you to memorize. All right, the first 20. You might be saying, why are you asking us to memorize this? Because by memorizing it, we're hoping that you can also learn a little bit about what its location is. Because when we start working with elements, we need you to be able to find them on the periodic table quickly. Because the location on the table is going to tell us how many electrons it has and how it's going to behave. So if I asked you to find sulfur, and you have to go to number 1 and start driving across and finding the word sulfur, you're never going to get your work done because it's going to take you too long to find it. So by memorizing the symbol, sulfur S, we're hoping that you can find it quickly and we can then do our work quickly. Yep. No, we don't need to know the numbers or the masses, just the names and the symbols. So what the quiz will look like is it'll have a list with some names, you'll give me the symbols, and a list with some symbols and you'll give me the names. Okay? And I have it already technically on Monday, but from your response, Monday's not going to work for some of you, so I'll switch it to Tuesday. We'll do that Tuesday just at the beginning of class. All right? So the first 20, and I'm going to continue on just for the sake of time, but you can always go back online and finish that list. And then there's a handful that are not the first 20 that I also want you to try to find, and that's because we use these a lot. Copper is a very common element, all right? Yeah, some people are taking a snapshot of it. It's a good move. Copper is a very common element. Iron, nickel, all right? Iodine, all that stuff there. So my quiz on Tuesday is going to be on the names and the symbols for those, so for that group, all right? Sorry? No, don't worry about writing it down. You can always go to the Google Classroom and open up the notes, right? You can always go and find that, okay? In order to memorize it. So when you sit down to memorize it, you can open that up and you can memorize that. Some people took a picture of it. If you want to do that, you can. I don't care. Do I want to do this song? No, I really don't want to do the song right now. I'll go back and do it. No, later. But come back to it later. Okay. I want you to write that down. These are the specialized groups. I'm moving too fast. It's okay? But it's okay? You're listening? You're catching everything? All right, that's good. There's not a problem. Now at this point, I'm going to hand out the blank periodic table. And you could try to write right on that blank periodic table. You know what I mean? I wasn't sure how well that was going to work. That's why I made a printout for everyone. I wasn't sure how well it was going to be, how easy it was going to be to label these on here. So I made the printout. But if you like, if you've got it mastered and you like that procedure, because in the end, I'm visualizing you studying purely from Google Classroom, right? To get the notes and all that. Hey, that's fine. That is fine. I'm imagining you guys kind of studying using a combination of both. You know what I mean? A little bit out of your notes and a little bit going to Google Classroom. And I have lost, the rubber finger I use to hand things out. I got another one. Thought I did. Clips. Allows me to hand paper out nice and easy. So you don't need one? See, years ago I'd lick my finger, and then I'd start handing it out. And I had a girl in my class who was very much a germaphobe. And I would lick my finger, and she sat in the front row, and then I would put my finger on the paper, and she looked at me as if I was transferring the most disgusting germs in the world to her. And it was actually right around the time when there was a respiratory illness called SARS, and it was affecting Toronto and some other countries, and it was quite infectious. So everybody was getting a little excited about this respiratory illness. So I thought, yeah, that's a little disgusting. Maybe I shouldn't do that. So I went and I purchased these little things. Okay, what I'd like you to do on your periodic table that you have just obtained, all right? Again, you can label the group numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then what I'd like you to label on them is the transition metals from 13 to 12. Make some lines down here. You can color it if you want, or you can do whatever. Some people, well, Eric has already zoomed in. He's taken the blank one that I gave online, and he's labeling it using the labeling method. You guys can do that right on your paper, or you could do it online. I really don't care. Yep. Oh, okay. So you printed it out?
Yeah, I have.
Oh, you can use this one too. You just want to use the one that you printed?
Yeah, and it's already colored.
Oh, nice. Oh, go and get it then. Go and get it. So, transition metals right here. You're going to put a line down here, a line down there, and you're going to put transition metals in the middle. Right? Transition metals from 3 to 12. Actually, I can show you the way it looks on here. I can actually write it in. So, down here from here, down here from here, transition, oops, it's a T-shun, metals. Yep.
Can I get a paper one? Because I just realized.
Not a problem.
For the next element for helium, there's a box right beside it.
Ah, this silly little chart has an extra box beside helium. Ignore that extra box beside helium. Yep. What's that?
How do we write that in?
You're going to write it just on your piece of paper. We're not putting elements on that table. This table is going to be just for the groups. So you don't need to write all the elements in them. You're not creating your own periodic table in this case. You're just using it to see the groups and where they're found. Okay? Everybody kind of understand? Group 1. Again, I guess I'll use a different color, but you're going to use your own. I'll bring red down here. And I don't have a whole lot of room, but I'm going to write it sideways. I'm going to write down alkali metals. And mine is very scribbly. And in group 2, you're going to write alkaline earth metals. Alkaline earth met. Even just met is good enough. We get the idea, right? They're the metals. You can use different colors if you'd like, but you don't have to. It's up to you. This is your note. In the end, that's what you're going to use to study which group is which. Group 17 is the halogens. Again, I'm just going to use a different color for no particular reason. So I'm going to isolate 17 right in here. And I'm going to write down halogens under 17. Halogens. And group 18, noble gases. Noble gases. All right? So you might be responsible for telling me what group an element is in. So if I were to ask you, iodine, What group is iodine in? It's a halogen because it's in group 17. The blank periodic table is nice because you don't have a whole bunch of elements on it in the way. You can write it down. I didn't write in what is called the representative elements, but that's simply everything except the transition metals. And these guys down at the bottom. These guys down at the bottom, they're really big. We don't talk about them either. So it's these two, and it's like we pretend that these guys in the middle don't exist, and then these guys here. They're the simplest of all elements. It's really easy to explain the way those atoms behave. So in an introductory course, that's all we really study in this course. We won't study how the electrons are around a transition metal because it's very complicated. Okay? So I need you to be able to know which groups are which. So if I talk about a halogen, chlorine, and the way it behaves, you'll understand what I'm talking about. Okay. Have we got it all labeled? Brett, you got it labeled? Nice. I am going to get to the label, the last two there. And is that even on my thing? Yes. Lanthanides and actinides. We're not going to study them, but they're down here. So one last division. Run a line across there. The top one are lanthanides, and this one is actinides. Actinides. And then we've got it. Fancy terms, lanthanides and actinides. The only reason they're called that is because of the element that's at the beginning of the row. This element here is lanthanum. So we call this group behind it the lanthanides because it starts with lanthanum. There's nothing special about it. This is actinium. So it starts the actinides. All right? Okay. Question? Sorry, question. I didn't hear that. It's called the halogens. You can go around behind mine. The halogens. Oh, group 17. It's right beside the noble gases. Halogens right there beside it, right beside it. These other guys in here, they're important, but they really don't have a distinct property. Their properties are kind of mashed together. These guys, though, are distinct, so they get their own name. This is just where I've already done this, and you can see and make sure that you've got it. Whoops, that you've got it in the right. Whoops, I'm missing one. Got it in the right spot. Okay, everybody looking good? So I'm going to stop my video at this point, and to finish off, there's a practice worksheet with things like period and group and which one is this in and which one is this in. That's what you're going to finish off today with. It's not to be handed in. That doesn't mean you don't do it, though. It's a practice sheet, right? And you guys can then go ahead and work on that right now for the rest of the class. You want to hear the element song? I think I have to stop my video first, so I'm going to do that first so I don't mess anything up because I don't want to lose my audio. Save.